Today we will solve May 2020 paper 1. First question asks you about wave behavior. Which one is the total internal reflection? Total internal reflection. This is the refraction and this is the reflection. State two properties that all waves have in common. I can say all waves can reflect, all waves can refract, all waves transfer energy without transferring matter. I can say also all waves have amplitude or wavelength or frequency, so I can use any one from them. So I can say all waves can reflect, and also all waves transfer energy without transferring matter, The second question. This question is about the movement of a train. The diagram shows the train on a track. The train starts braking at point P and stops moving at point. The graph shows how the train's velocity changes with time as the train travels from P to Q. Okay. Calculate the acceleration of a train. This is the velocity time graph. In motion, velocity time graph, the gradient is the acceleration, or I can say slope is acceleration. So I will get the slope for the line. Okay, so acceleration equal change in velocity over time, or the gradient of the velocity time graph. So I can say this is 45 and this is 39. Okay, so the gradient equal negative 45 over 39. Why I put this negative? Because it's deceleration, not acceleration. This is deceleration. This line, I told you that this is deceleration. So negative 45 over 39, by using calculator, it will be negative 1.2 meters per second squared. This is the acceleration. Calculate the distance traveled by the train from P to Q. Any velocity time graph, area under the graph is the distance, and slope or gradient is the acceleration. So he need the distance, so I will get the area under the graph. Area under the graph, you will get triangle or rectangle. Rectangle, area of the rectangle, it will be base times height. Area for the triangle, it will be half times base times height. This is a triangle, so it will be half times base, which is 39, over height, times height, sorry, 45. By using calculator, it will be 880 meters. Draw a line on the graph to show how the train's velocity will change if its initial velocity is the same but the braking force is lower. Okay. It will be decreasing velocity from same initial velocity اللي احنا بدأنا بيها من الجراف. Same initial velocity. It will be shallow gradient. Like this, from the same initial velocity. Not like this, I'm using tablet so it's not that good in drawing. Yes, something like this. The third question. This question is about stars. Describe the stage and the evolution of a star similar in mass to the sun. Okay. Let's start with nebula. And then nebula become a protostar. And then protostar to main sequence. From main sequence to red giant. From red giant to white dwarf. And then from white dwarf to black dwarf. Let's move on. The process of energy release in the core of a star is different to the process of energy release in a nuclear reactor and a power station. Describe how these processes of energy release are different. Okay. Stars use fusion, but reactors use fission. Stars use fusion, but reactors use fission. Fusion is the joining of nuclei. We have two nuclei and we have make it joining of nuclei. But fission is the splitting of nuclei. We have one and become two, it becomes two, so it will be splitting of nuclei. So fusion, joining of nuclei. Fission is splitting of nuclei. Splitting of nuclei. Let's move on. State Hooke's law. Simply, Hooke's law is the extension is directly proportional to force or load applied. Like this. Extension is directly. ركزوا لما نكتب كلمة directly or inversely في أي question you will get 2 marks. You will gain 2 marks because كلمة directly أو inversely لوحدها it gains 2 marks. So extension is directly proportional to force. The graph shows how the extension of a rubber band varies with the force applied. Explain how the graph shows that the rubber band doesn't obey Hooke's law. Simply, it's not a straight line. Okay, it passes from the origin, but it's not a straight line. Hooke's law, you must draw a straight line pass through the origin.